Hello everyone, this is Bradley. This is almost February 2021, meaning less than 1 month later, Blender 2.92 is coming out with its new geometry node system. Today this is not a tutorial but a discussion with possibly some examples using geometry nodes. Before we head into the main topic, I want to answer the question that people frequently ask me these days. The question was whether geometry node is going to replace animation nodes. Firstly, I need to clarify that the geometry node is under a so-called everything node project. This project intends to make Blender more procedural. Therefore, we are going to have a particle node, geometry node, and potentially other node system in the future in Blender. Then, to answer the question, the short answer is no. There are many points that I can make. I even wrote a paragraph to answer these questions in the past, but I'm only going to pick those which are the most important points here. First, in the past there were 3 instances, each explained by different developers, that animation nodes was not part of everything node project and would not be integrated into Blender, which means it will be kept as a separate add-on. These were more than a year ago, but things may or may not change now or in the future. However, I hope you to get an idea about how developers used to thought about the animation nodes in relation to everything node project. Also to add that it has been just mentioned recently that animation nodes may add support to geometry nodes. So I think very likely the animation nodes will still be a separate add-on, and everything node project will not cover animation nodes. The second point is that everything node project is a very big project. Geometry node was just a start. I don't know if you know, but at the very beginning, the particle node was worked at the most beginning that we used to have a functional branch. Its main developer, Jacques Luc, who was also the developer of animation nodes, even made a presentation and a survey about the UI design of particle nodes. And the functional branch, which used to include particle nodes, has been disappeared for unknown reason. And suddenly we started to have geometry nodes in 2.92 without any trace of particle nodes. I simply want to say that it takes time for things to develop, but on the other hand, things may be changed very easily. However, if you're working with Blender very seriously, then your job, your client, your work are not going to wait everything on the project to develop. So please think about this issue carefully, whether to learn animation nodes or not. I'm not proposing you to learn about animation nodes because many people don't need animation nodes to do their work. I personally cannot live without animation nodes, but you don't necessarily to follow me. But still get a kind of idea. If you really need something procedural about the modeling or other things, you probably would like to take a look within animation nodes and most likely actually the Troubleshotting. The third point is that even if both softwares or tools can achieve the same result, user experience with them may not be the same. This is the main topic of today's discussion. The developer of geometry node is also Jacques Luc. Nevertheless, even beyond my expectation, geometry nodes turn to be so different from animation nodes and may not even be similar to shader nodes. It's so unique in which there are pros and cons to issues that we're going to discuss. So let's start. So here we're in Blender 2.92. I first would like to show a kind of setup in animation node because I think it's kind of very model systems. And since the developer is the same, I used to think the geometry node is going to be similar to animation nodes. Let's play the animation. Basically, this animation is just that you generate random points and it connects these points into splines, and you output this spline as a actual object. Kind of very simple, just a spline wiggle. I don't think practically it will be any interesting animation, but this is just an example. What I actually want to tell you is that you can see the color of the sockets are different. This is the same as the Blender, that when you have a different color socket, it means different data type. And if I input a kind of light, the purple, but I output blue, but if I input blue, it output pink. So it means data has been changed or formed during the entire process. And this is kind of a very representative model system. And this is not unique to animation nodes. When you look at the shader nodes, you basically do the same. When you have different input data type, but you finally output a completely different one. Okay, there are many different types of sockets. However, this thing does not appear in geometry node. Geometry node actually has simplified the entire things into more simple stuff. So we first need to have a geometry node. The geometry node is mostly initially designed as a node-based modifier, which means you at least need to have an object which accepts the modifier. On the other side, which it actually means that you cannot have geometry nodes on metaball. You cannot have the geometry node on empty. You probably cannot have geometry nodes on light, but you can use the geometry node to control light. But these are the things that you have to think about. So look, let's just take a plane, and as I said, it's a modifier. So one way to add is you go to the modifier and you can add a geometry node. So this is one way. The other way is you go to the geometry node editor, select the objects, and let's just delete this modifier at this moment. And you just hit this plus icon, it will add a geometry node modifier automatically to you. Sometimes if you select elsewhere, that the geometry node will disappear, or select other object, then geometry node will disappear. For example, I'm selecting the cube, I can no longer have controls within this geometry node. Personally, I like to click this pin icon, so pin this entire panel so that I can keep working on this thing even if I'm not selecting this object. To call up the node, you shift the A and there is a panel. I just realized recently that if you right click this search bar and you can add a shortcut, change a shortcut, remove the shortcut, and do whatever things you want. So I make that a to control A. However, if you're not familiar with the geometry nodes, then you probably would like to use the shift A for a while until you're actually familiar with what kind of node you have. And to learn a node system, this is equally true when you're working with geometry nodes, animation nodes, and search arc, or even shortcut, is to look at the menu or find a way to actually know all the node it has. And that's why shift A, if there is no menu, then shift A is the best method that you can use. And the geometry node does not have many nodes yet in Blender 2.92. Oh, by the way, I also would like to remind you that whatever you're having right now in Blender 2.92 beta is the functionality that you will have. And if you do not have features in Blender 2.92 beta, it means you are not going to have that in the final release. So if there is a limitation, for example, there is a subdivision surfaces node, but it does not support the adaptive sampling functions, then it means you are not going to have these functions in Blender 2.92. There's no new features will be added at this moment. Maybe it already appears in Blender 2.93, or it still waits a very long time to have that features done. But at least at this moment, you do not have these features. Okay. Although previously I've mentioned that the geometry nodes, I think the most initial design is in order to make a node-based modifier system. But unfortunately, now you don't have actually many choices of the modifier. So you go to the mesh, there's only 4 modifiers that you can actually use: Boolean, edge split, subdivision surface, triangulate. Maybe you will add more functionality in the future, but now you just have no. Instead, actually it becomes very interesting. They actually added this attribute system. I think this attribute system is going to be the main system that you're going to work with in the future. This is something which is very weird. Currently, what people do mostly with these geometry nodes actually is to work that to instance the object. So there is a node which is called point instance. Let's take a point distribute, and we no longer actually need the subdivision surfaces. Oh, by the way, talk about a pros of geometry node is that because it's part of Blender, so it's integrated well in Blender with your Control X. Then you can delete the node while reconnecting. These kind of things does not occur in animation nodes, unfortunately. I think it neither occurs with procedural, but anyway. So point distribute, you just it's kind of a similar kind of particle system work, and you just increasing density, then you increase a lot of these particles, which is there is also a Poisson disk, but I actually don't really understand what does it mean. But usually you just use random. It does not really matter. So you instance all these kind of points, and you can use the points in the instance, select the object, so you are actually instancing real object. So let's just select this object, then you're instancing all these kind of cubes. This system has a very good advantage. It sounds to be faster, but I don't have a numerical data about how fast it is. This is also different from animation nodes. In animation nodes, you will have, so let's go to animation nodes. So in animation nodes, you will have a time information which talks about the execution time of this node tree. So if your node tree becomes heavy, put a lot of stress on your machine, you will know the results. In geometry node, you don't have this kind of thing. So I don't know when my computer will actually stuck with its calculation or how fast it is. I don't think this feature will be added, because if they are going to add this feature, they will actually do this very long time ago. So unfortunately, it does not exist. So you point and distribute everything. Okay, this is supposedly to be a faster system, distribute all these kind of cubes. And then what if I would like to move these objects, some of the object upwards, like the animation nodes? Because people keeps asking whether geometry node is going to replace animation nodes or other things. In animation nodes, of course, there will be a very simple system to do the mograph, as I have shown in many of my other tutorials. But how are we going to work with geometry nodes? And then it comes to be a topic about the attribute system. So there is a node which is called point translate. You can see there are two types of translation that you can have. One is a vector. If you just put a vector, it's very simple, very straightforward. You just move that up and down. Very simple, very dumb. But you also realize, because you're putting a single vectors, which applies to all these kind of points, then you don't have a differentiation. Okay, you can definitely do this, but why not just move our planes up and down? You don't necessarily to have a node for this function. It does not make sense. Another important thing is I want to only have a part of the sphere that moves up. Then you really need a fourth system. And the geometry node does have a way to mimic a fourth system. This is what we're going to discuss. But it also means that we have to use a function which is called attribute. The attribute is basically a property. This is actually very weird cases. So currently the included attribute, including the points, the position, and the scale, and the rotation. But also many other cases, like potentially the normal, if you understand what a normal is. Also the UV map. Maybe there's also other attribute that you can potentially have. Oh, actually the weight map as well. This is something that maybe I will discuss later. Basically the weight map is when you have a vertex group, then you have a weight map. You can assign, you can even paint. This is something that I may discuss later or not, but it does not really matter. This is not a tutorial, this is discussion. On the other hand, you can actually create attribute. If I just type in a W, it will not cause any errors. It will just generate an attribute of W. But the computer obviously does not know what the W this is. So there is a node which is called attribute field. So let's clean up. So if I take this attribute field and put this into place, then you can see now if I take this W into 1, then this entire point has been moved to a weird place. What it happens is when you put a value of 1, and you put you put that as a translation, then you're actually generating a vector value of 1 1 1. So it moves 1 unit away on y, 1 unit away on x, and 1 unit away on z. Finally, it moves everything to here. Okay, this is how it works. So this is also a very interesting feature in Blender, because in shader nodes, let's look at the shaders. Let's get another panels. Let's get the shaders. Where's my shader editors? In shaders, although you have different data types like yellow, blue, and gray, but basically all these kind of color and the vectors are the same thing, or they are interchangeable. For example, you can have a combine XYZ, which outputs a purple color, but you can put that into the yellow socket. And just taking a look with what it actually has. So if we go to the data preview mode, if I put the X to 1, it means red color, because it transformed everything into RGB automatically. This does not exist in animation nodes. Animation nodes has to really make every data type very specific. The vector is something that we just discussed, that it's combined XYZ. But when you're talking about the rotation, it's Euler. That's why you have another series of node, which is Euler wiggle. And you cannot directly put the Euler into vectors. It will have to regenerate everything. For example, vector to Euler or Euler to vector. You have to make a conversions. The native Blender do not need all this kind of conversion. Also, there is a cases. For example, you can combine color. As I previously mentioned, the vector is basically the color. Okay. But in animation nodes, it's different. So this is the difference between the native Blender and the animation nodes. There is a reason that the animation node has to do such a way. This probably is legitimate, but there is just sometimes it makes things chaotic, and because you have to do all this kind of conversion, sometimes it makes kind of node tree large. So color cannot directly put into points, not something that actually occurs previously in the shader nodes. And this is not something that is going to occur within the geometry nodes. Also a cases that, as I just explained, when you put a float, it will automatically convert everything into a value of 1 1 1. So that transform our points in such kind of way. But if you just directly, but in animation node there is a node which is called a vector from values. So then you put a 1, you generate a vector of 1 1 1. So you need to take a specific node to achieve a function that does not need a node in Blender. So this is a very good advantage when you work with native Blender. That's you do not need to do all this kind of conversion. You don't necessarily even to actually understand what's the difference between vector and Euler. Or there are actually many other data types, how to do the conversion, and so on and so forth. In Blender, you don't need to think about this. However, it also causes a very huge problem. That if I'm just showing you a node tree, and I'm telling you this is the attribute which is called a W. So you may think, okay, what the W is? Is that a vector? Is that a color? Is that a scale? Is that a rotation? Because Blender do the conversion automatically, then they are numerically they are the same. The locations, the position, and the rotations, and the scales, colors, everything becomes the same, numerically the same. But it still does not make sense, because when I'm looking at the shaders, a location of 1 1 1, I know this is the red color and its value in terms of vector is 1 0 0, but how does that actually make my life better in order to understand this entire node tree. Because color and position are two different things. You make them numerically the same, but it does not mean I will understand them equally. When I'm having a vector, for example, my sphere, which is at a location with probably -111, which is at a location of 230, then I don't care about what color this will be, because I treat this XYZ as a location. On the other side, if I have a color code, for example 0.5, 0.5, then I need to understand this is blue or green or cyan color. So to conclude what I just suggested is that this attribute can be location, position, scales, rotation, and color, unless you name that very accurately, like a rotation 1, or name that, unless you name that very precisely, or you just name that very simply. Then if you share this node tree to the others probably won't really directly understand about what this is, because this f can be anything, while it's not everything. So let's move on within these node trees. We fill these attributes with an f. So if let's go back to the geometry node. Let's turn this geometry node back on. And let's just name it as a T. The reason I don't usually use a very precise nomenclature, because when you have many different attributes, you have to type all these kind of words. For example, I have to type translation, and I have to type translation. It becomes very chaotic. So usually just TT. Either name is just a translation, because you are creating attributes by yourself, so it does not really matter. As long as it works best for you, you can just room up this entire node tree as much as you like. So this is also an issue, that if I share this node tree to the others, I probably need to actually name everything correctly. Or another important thing, actually, I forgot to mention, is at the most beginning, I showed you an example that you input the purple, you output the blue, and then you input the blue, you output pink. This is the way that's how the Blender used to work with. This is kind of a very representative example, even in shader nodes, that you input a purple and to the yellow or whatever, finally output a final gray. Basically a different data type conversion. In geometry nodes, you don't have all these kind of things. Basically what happens is you input green, you output green, you input green, output green, you input green, output green. Everything is just like green. The geometry node is such a very big idea that it will include all these kind of attributes that you just created, and all these attributes that it already includes. And this is kind of, I think this is how Houdini, I think this kind of get idea from Houdini. But I don't think this is how Houdini really works. There must be something wrong. Maybe this is kind of Blender ways of Houdini workflow. But if this is really how Houdini work exactly, then I'll probably think this is a little bit dumb. Another thing I would like to remind you is we already make this attribute field, and we put this attribute into the information, which is a very huge data collection, which is called the geometry. So the geometry node, the geometry concept is much more broad than what you can potentially imagine. So when I tell you there is a data which is called geometry, I'm actually not telling you anything specific, because without me to tell you, you probably don't know that the geometry will contain an attribute that I created, which is called a T. And even if I tell you there is an attribute which is called a T, you probably don't actually get an idea. So what is T? I can also rename that as W. So what is W? What is F? So this is kind of a very tricky moment when you're working with all these kind of attributes. You can name that whatever you want, and you can also make that whatever data type you want. And again, vector and color are actually the same thing. I don't know actually why it's separated into such a case, which turns to be so weird. But anyway, so looking at what we are having at this moment is we're generating a attribute T and put that into geometry data collection. If we do not make the node tree look like this, then you put the geometry directly to geometry. So we are trying to translate all these kind of points with a attribute which is called T. Then because we added the geometry data collection in this output, this location, okay? And this geometry data block has not actually been input to this geometry data block. So this geometry data block does not actually know what this T is. That's why there is no translation. So you have to put this geometry that includes the attribute which is called T to the geometry data block which needs a T. This sounds a couple confusing, but this is how confusing it is. Which actually also means that if I create a attribute which is called T right here, but I don't necessarily use this geometry, I can take that to F and I can make another attribute field and call it F. So I can create a T while I'm not using that. This is something that can very much occur because sometimes I probably just mess around the entire node tree. And without you really reviewed your node tree carefully, probably just keep that as it is. Because when you look at that, wait, what is T? What I would like to do with this T? Anyway, so up to this moment, my tone may sound to be sarcastic, and you probably think, okay, because this person makes a lot of tutorials about animation nodes, he must have a bias against the geometry nodes. I would say no, but I also won't deny the possibility that I have a bias. But these are the things that can actually cause this problem. It becomes especially kind of prominent when you look at other geometry. These are really possible things that will actually occur when you're actually working with geometry nodes. And this is something that we'll discuss. So go back to our most initial point that we're going to make kind of a differential translocation of all these kind of point instances. We're going to take a attribute vector method. Again, this is not actually a tutorial. This is a discussion. But because it's more efficient when we are making a kind of discussion, then we just have to deal with this. Let's just simply think about the vector attribute vector math before we actually head into a real topic. When you have this attribute vector math, there is actually these many ways of calculation. I think when you look at the vector math, there's still much more. Does it? No, actually they are the same. But if you take the attribute math and the math, you realize Blender has these many math functions, but the attribute math is just 4. Which means this is a limitation at this moment. Actually, this shouldn't be real limitation. I don't know why they just didn't add these many functions. I think there's probably some reasons, but I don't really understand at this moment. It's kind of very tricky, but it also means this is really at a very early stage of development, because you cannot actually put all this kind of value as an attribute. You can probably use attribute field, but somehow there's some issue here and there. There's not the same. A more important thing is that you cannot view your results of your attribute. There is no such a node which is called attribute input. So if you go to Shift A, these are all the nodes, all the attributes nodes you have currently in Blender 2.92. You cannot actually get information or retrieve the information of attributes. This is something that we will discuss later. So talking about so let's take a distance. And I'm going to name the attribute as position. This is a legitimate attribute which is called named position. This is also very tricky part because in the menu it does not tell you or it does not directly tell you what kind of attributes are legitimate, what kind of attributes are not legitimate. In fact, all attributes are legitimate because you can name whatever you want. You can name that you can name that whatever crop you can have. What I mean legitimate is whether this is some information that you can really retrieve from Blender. For example, position. Let's just show. If I take geometry into geometry, if I just type position, then you can see all these kind of points just be separated 2 times. Because when you add a position, their original position is called a position. They're originally at a position, and you add one more position, it means that they are just going further, like 2 times away from their original locations. And this is why you have seen this kind of interesting effect. The position, the point which is already here, has been gone there. Everything has been moved 2 times, which means this position is actually legitimate attributes that you can retrieve from the Blender. But my question is, why they cannot be actually called a location? Because I think a location does make sense more. And looking at the menu previously, that I do not really find information about what kind of attributes is something that's already existing in Blender, and what kind of attribute it does not. For example, I originally think, okay, we should call everything as a location, because location is still a word, a synonym in dictionary. But the location does not work, and only the position works. I'm not saying this is bad, but I want to know where I can actually know the actual name of the data type I actually want to get. If I type rotation, it actually works. At least you get a kind of result. If you get a result, it means this data type was something that originally existed in Blender. Scale probably, I don't know why actually scale does not really work, but the scale is a legitimate legitimate attribute. But anyway, so what we actually would like to do is take a distance, and I'm evaluate that to a vector. Again, this is not a tutorial, so we use an object info, and you can just create whatever empty, and I'm going to actually clean about all these kind of whatever things in outline. Empty goes to locations, and then we have to generate a result. The reason I said it's tricky is because if you really, so let's firstly just see kind of result we can actually get. Why I'm actually taking a result of P1, I'm just creating a result of P1. You can name that whatever you want. You can ABCD and ABCD. It still works the same. It really depends on how you work. So most case I just keep that as simple as it is. T, I take T because translation. The most initial case of translation. Yeah, this is it. And it's very close to my left hand, while my right hand is working with the mouse. I can definitely take that P as well, but it's very far away, so I don't like that. Okay, so it takes kind of results. And a very big issue with the geometry node currently is that we don't have a viewer. So this is not like animation nodes when you can W goes to viewer, you can see all this kind of value actually output. So which also means you do not actually know how your value has been changed during this entire course. I don't think the viewer function will be added in the future. Or maybe they will, but I really don't know, because what you output is a data block which is called geometry. Geometry contains so many things. It contains position, contains T, contains rotations, contains scale. So if you are going to have a view of this geometry, it will actually output billions of information that you are going to have. It's not realistic. I think this tends to be a very huge limitation with this system that you are not going to view. Maybe there are some other ways that you are going to there is going to be a failure in the future. Like you can retrieve the information about T or A, B, C, D, but at this moment it's not possible, and I don't know how it will be solved in the future. So what I want to say is you don't actually know how things will actually be changed. What it happens is, what actually you get, the distance is a single value. So originally you have vectors. You are measuring the distance from vector to vector. For example, this point to this point, the distance is 1. And it finally turns to go back to the most initial cases where we actually use an attribute field, that you use a float to generate a 1, but the actual output becomes 111 when it has been used as a translation. So this is automatic conversions in Blender, as I mentioned earlier. And that's why it happens, it goes to that direction, which everything is positive. Okay. And because the different distance from point to point are different, so there is a differential of all this kind of translation. So we actually already get our result back very nicely. If I would like to eliminate I only want to translate on z-axis. So I would like to eliminate the translation on x and y. So usually, if you're in shader nodes, sometimes you may think, okay, we can separate x, y, z and combine x, y, z, and I only put the z's into z so that it only will translate on z. But you will find that there is no way to actually do this kind of thing. There is no such a node which is called separate attributes. There is no way which is called combine attributes. Actually, combine attribute, you can just use attribute field, but you don't have a way to separate the attributes. And more importantly, you cannot actually get a way to get attributes. There is no way to get an attribute. Like, I want to use this attribute T, get an attribute T, there is no way to separate. So I cannot put anything into this location to separate that and combine that. So these are two different kind of workflow. This actually also explains the fact that the attribute system and the normal the system that we used to have in shader nodes are not actually connected to each other very well. The only way that you can potentially do is that you have this kind of numerical system and you can use the attribute field. But there is no other way around. You cannot put the attribute and put that into the original math function. And thinking about the previous I mentioned, the attribute math only have 4 functions. But these are really just the 4 functions that you can use with these attribute math. And even if we have a more operation that you can have in the normal math function, you cannot use any of these 4 attributes. It's just not possible, which is very unfortunate at this moment. Everything may be changed in the next version, but not in 2.92. This is the reality. And I don't know how it will be changed, whether it will be actually changed in 2.93, because it's just too far away. Anyway, going to our most initial location. So how can I actually achieve the result? It's actually also very simple. You just multiply everything to 0, then you cancel the entire translocation. If you time this, so this t actually means the value of x, y, z. Currently they are the same value because they comes from the same distance, which goes to x, which goes to y, which goes to z. And I only want to output z translocation, so I'm just take the multiply to 1 on this vector, but we need to times t to t. This also turns to be a very weird moment, because if you really think about this node tree, this is kind of very weird. Let me point out what's the place which is weird. If I have a math function 0.5 plus 1 plus 2, and the value equals 3, my question is this 3 the same as the previous 1? Then you probably think, of course 3 does not equal to 1. They're not the same thing. But on the other hand, this probably turns to be a little bit philosophical, but this is actually true, that there is a person which is called John, and he was 3 years old, and now it becomes 18 years old. And are they the same person? Maybe the John becomes taller, more mature, stronger, but John is still John. It does not really change that much whether he's 18 years old or 3 years old. I mean, it depends on how you think, but I would say in this case, John is still the same John. He must be changed, but he's still John. You cannot really deny his social security number or whatever identities, because you cannot put this 18 back to 3. If it does, please tell me. You can invent a time machine and win a Nobel Prize, definitely. But anyway, so this is what actually happens if I input a t and my result is still t. So you may think, okay, what happens with here? The attribute vector mass, I input a position and output t. Can they be the same? I think technically speaking, they can be the same. But I suppose for some reason, the position will be kept as position. If you type the position here, it will just add everything 2 times as I have shown you earlier. The position will not be changed, so you have to make that a different data type. While here, you can put the t as the same t. But of course, you can make that as a difference, make it w. You still do the same. But it's just meaningless that you're creating the meaningless attributes, which are essentially the same thing. Like you're intentionally separated 3 years old John to be different from the 18 years old John, which is kind of making things more chaotic because you're just creating more attributes. Considering a moment that you're having billions of attributes, for example, I'm taking more attribute mass. I'm adding this w to 2 times to add 1, and I finally translate more f. And I'm adding another vector mass to make this f to be more like y, and translate y. This is not a practical case, but you can definitely happen. That's it. Then I'm just meaninglessly creating more attributes. I have attributes which already exist, which is called a position. Then I'm creating an attribute which is called t, creating an attribute which is called w, creating an attribute which is called f, creating an attribute which is called y, creating an attribute, it's still the same attribute which is called y. But in reality, what can actually happen is you can name everything as a t. It's do the same thing. But when you think about this node tree, it's not actually very clear to read, because you think when we are actually working this small attribute mass, I have so many characters. You feel like we're actually doing different things, but it's still the very simple thing that you're actually putting a vector mass throughout. A vector mass. In reality, just a vector mass. You just put these values, put these values, put these values. Looking at the difference with this node tree and looking at the difference with the data block that we are having, what I want to say is when you are output something, everything becomes very streamlined. You know where my output has been gone to, and you know where my input has been received from. You know the value is still the same. You know the value has not been changed. But when you're looking at these attributes, it's not showing in the form of this kind of node tree, because geometry is a very vague concept, as I explained earlier. But the attribute is very solid things, but the attribute is not connected to the attribute directly in the form as what we used to have. So it causes confusions. There are pros and cons, probably, but in this particular case, so the pros is that you don't have all this kind of spaghetti, because I can have values connected to here and here. So now I have 3 spaghettis. When the node tree grows large, then I have billions of spaghettis that you can find in many node member, node tree, or so on. But in this case, everything is named t, which means the property actually jumps. I get a t from this t, but I'm not linking these t's to that t. I don't know if you can actually get that kind of idea, but this is how it works. Which also means, because everything has been actually included within this data block. I don't know if you actually understand, but really think about this kind of issue. I'm getting the t from here, but I'm not linking these two places as I'm actually doing with this math. Because what happens is we put everything into a data block which is called geometry, and we are putting geometry, the entire whole things, into the next collection, and we are getting the t from this data block which is called geometry. So we only connect one geometry, but we get multiple data at the same time. I don't know if you understand, but this is really think about these kind of issues that you're going to have. And as I said earlier, you can create as many attributes, but most of the time it just creates problems. So let's clean up these two vector math. So now this is the shape that we are having, but when we're discussing for, sometimes this is a little bit actually reversed from what we usually think. I want to have the midpoint to be highest and the rest of the point to be lowest. Easiest way is probably just times -1, so everything has been drawn downwards instead of upwards. But this is just kind of how should I say, an illusion about how these things works, because everything goes reverse. But maybe you can really do this. I think this is also a legitimate way, because who actually knows where the floor is? You can define the floor by yourself, right? But what if I really would actually make this kind of more serious? The way is to use a function which is called color ramp, attribute color ramp. This is also a very tricky node. If you work with shaders, then you know what this color ramp is. But how does it actually mean with our what does it actually mean with our attributes? So basically the black is 0, white is 1. It's just another form of a map range. You have the minimum, maximum, 0 to 1, 0 to 1. So left is minimum, right is maximum, and the minimum is with black, which means 0. Maximum is with white, which means 1. So it's 0 to 1, 0 to 1. Very similar. Then what you need to do is to input a value, and you actually get values from the geometry data block. So we just named our values. So just name these values. Let's name that as a t. Put that into geometry. And after we remap these entire things, 18 years old John is still the same as the what's that called? 3 years old John, yes. And because we remap the later everything, the same issue just actually occurred. So what we need to actually do is put a color ramp after the entire remap. So now everything has been fixed. Not really. Now what actually happens is that we are actually clamp these kind of edges. We've clamped these edges to be the plane. Okay. A little bit kind of weird cases. If we would like to reverse the entire thing, we just reverse this color ramp. So everything has been reversed. And now you can actually define the height or other things. Now problem has been finished. People ask the question that is that possible to, because if you're working with fourth in animation nodes, then you usually think, okay, if I scale up the fourth, decrease the fourth, then it will affect our fourth. But how is that going to affect our cases in this? This also turns to be very tricky. I don't actually know. Honestly speaking, I don't actually know. The way you can really think is if you put a multiply and you put the t's and you multiply with the scale, it's still t, and then you're actually increasing the value, but not you're not actually increasing the magnitude. I think the reason is when you clamp that to 0 is actually too much. So maybe this will, oh, actually it still does not actually work. So I actually don't really know. If you have the answer, you can drop a comments below. But I don't actually know how to actually create a fold. A kind of nice fold which cover the edge, and while I'm increasing the empty size, it also increase the other case. I'm not exactly know how to do. Maybe I just get a kind of short circuit in the morning because I'm so tired of making all these kind of things these days. But this is really kind of issues. And even if we made the kind of proximity fold, it's just one of many other types of fold that we are having with the animation nodes. With the fold, so we have this many fold: fade fold, delete fold, wiggle fold, render fold, noise fold, index, mask, object controller, sound, sublime, mesh, texture, whatever. But we are even struggling with a simple distance fold, which tends to be very tricky. And I don't know how to solve this problem. And in case you don't actually understand what I actually discussed with animation nodes, the desired result I'm actually looking for. So let's just take kind of very simple example. Let's grid mesh point scatter, and offset matrices. Take a 3D viewer. So now we have a plane, and these are markers which you can instance all these kind of objects. And if you increase the amount, then we're having lots of objects that you can see with these markers. And if I were taking the translation, everything has been moved up. And if I take the objects controller and selecting our empties, put the fourth into fourth, and then I'm actually moving all these points upwards. And I'm going to take the collection. So if I'm scaling up this fourth, everything has been moved upwards, and by changing this fourth width, you can see the fourth width has been changed. So this is kind of the actual effect, the desired effect that I'm looking for. But currently I don't know how you actually can accomplish the with geometry nodes. And this is just a simple thing that you can potentially think about. Anyway, I'm actually a little bit tired with these many discussions. So you can actually get kind of comparison. I'm not saying that animation node must be superior with geometry nodes. And I'm actually very happy with development of every single project. But I want you to understand, but since people keep asking these questions, I want to give you a very clear answer. Even if you think I'm biased or other things, it's in a very early development. It has a lot of potential. So we don't know whether it will be really comparable to animation nodes or not, how strong it will be, how interesting it will be. But even if functionality wise they are going to be very similar, the user preference will still be different. And another thing I want to remind you is the geometry node was intended to be designed as a node-based modifier, and you do have all this kind of you do have kind of a modifier options, even if limited. Like you have a boolean, you have edge split, you have subdivision surface, you have a triangulate. Most of these functions like edge split, subdivision surfaces does not exist in animation node and has no plan to be implemented. So there is already function that animation node cannot achieve, but on the other side there is billions of functions that the geometry node cannot achieve either. So this is a question that you have to think about when you are wondering which one is better, which one should I learn, because they are not the same thing, and they will never be the same. And the learning curve is independent to each other. And at some point, I don't have issue with geometry nodes, despite its limitation. For example, you do not have a adaptive sampling in subdivision services or other things, but the animation node also has limitation, whatever. It's just I don't know. So what do you actually think? Have you actually tried geometry nodes? Have you tried animation nodes? Do you have any difficulty in either of them? If you have any thoughts, you can leave the comment below. But anyway, I think this is not a tutorial, so it feels like I'm just complaining, but I do think whatever I described is realistic issue that you will find when you're working with attributes. It won't really cause dramatic difficulty, but it is a kind of issue if you're working with others. If you're working with yourself, then you have no problem. Like I have no problem. I can just do whatever things I like, and I have no problem in any of these. But maybe new users will have problems, and also that people ask me whether I'm going to make tutorials with geometry nodes. Currently, I only do the noding. I don't do tutorials because this is in a very early development. Today I may discuss these things, but tomorrow maybe things will be easier due to the development, and my tutorial just becomes useless in the long run. So I don't really plan into. And also there is a very limited function. You can make things very fancy, but it does not necessarily mean it's very useful. It's just a piling up of simple techniques or other things. It's basically simple. And there are already lots of tutorials on YouTube. You can just take a look. So I don't want to make repetitive tutorials while this is kind of simple and easy stuff. So anyway, I hope you have a good day, and I'll probably see you next time. If you have any comments, you can leave it below. I will be very interested in the discussions. Bye bye.